Hello and welcome to the third episode of the NetScaler podcast. My name is Brian Huhn, and I'm joined by my co-host Jason Poole. Together we'll be exploring the ins and outs of application delivery and security, dive deep into stories from the industry, and learn about the business challenges that face IT teams and how they overcome them. Jason, when you're ready, can you introduce our guest for today?
Sure, I can. Thanks, Brian. Today's topic is a subject that for me is the big change between a load balancer and an ADC, and that is content switching, making traffic management decisions based on the content of a request rather than on its networking components. And joining us today to help us explore this is Tytgat, a veteran of the ADC world. And Jan is the general manager and co-founder of CoreLayer in Belgium. Jan, welcome to the show. You have a wealth of experience in modernizing applications and general traffic management using ADCs. Perhaps you can tell us a little bit about you and CoreLayer so our audience can position in their mind where you're coming from.
Sure. Thanks, Jason. So back in 2009, I believe I started deploying and upgrading some simple NetScaler setups for customers at my employer. And I know by the time I got a bit proficient at deploying a NetScaler, it was around the time that there were a lot of Microsoft Exchange 2013 migrations. So I gained a lot of experience doing those projects. And I think around 2014, I decided to go independent. I met Roel Schrijvers, who is the co-founder of some office at a PTech event from Citrix in 2013. And we kind of teamed up quite fast. So I got involved into another company in the Netherlands, and then we started working on multiple projects, developing our own configuration framework and so on, to simplify operations for the NetScaler so that we could work better together. Roel unfortunately passed away in 2018, so around that time I decided to launch a new company, so to speak, in Belgium, that continued the work that we did together at Salms. So that's in a nutshell, where I came from.
Oh, good. Okay. Yes. So you spent a lot of time working with content switching and with general ADC stuff. So I think that, how many, 2000, what did you say the year you, 2010? Microsoft?
2009.
2009. There you go. So
yes.
A wealth of experience indeed. Now, bringing it back to the content switch, and I said a moment ago, that I felt that for me, this was the switch away from load balancing, even into ADCs, even if they weren't sort of called ADCs. I think that terminology was coined by one of the analysts, Gartner or IDC or something like that. And for me, it's always been about treating traffic at a higher level, and it gave many advantages to an administrator, like the ability to route traffic to specialized servers and be more granular in the way that you treat specific users. These, to me, were the big ones. But how do you use content switching when you work with your customers? And what are some of the common use cases you deploy? And what are the advantages that it brings to your customers?
Well, first of all, the most common use case, at least back in the day, was the shortage of IP addresses in the IPv4 space. IPv6 isn't yet as prevalent as we want it to be. Because it brings a lot of challenges, not only to the application world, but especially on the networking side of things. So that was the primary the use case to use content switching, because you can easily provide access to different applications using the same IP address, even though they are available at different domains. So that used to be the primary use case, and the second one, in my opinion, was, especially when you look back at the days for Exchange 2013, for example, Exchange wasn't just one simple application. You had Outlook Web Access, you had Control Panel, all these different components that made up the whole suite of the Exchange protocols. And every aspect of that application required different policies. So either in terms of persistency, which rules you wanted to apply, those kind of things. Nowadays, if you're asking me around content switching, I would say that it's most of the time to improve the security posture of applications and documenting the different application flows that are being routed through the NetScaler, because most of the time what we see is that the business and then in terms of the infrastructure teams and the developer teams, they are not always aware of all the application components that are being handled by a Netscaler. So the Netscaler often can be used as kind of a documentation appliance as well, because in the way that we configure content switching, we have to explicitly define all the flows that go through. So if you look at our configuration in the Netscaler, we can immediately tell to the business, to the IT teams that this application or this component is being routed through the Netscaler or not. And that's, for me, is a big benefit, because Netscaler is always in the middle of everything, whether teams like that or not, but it's in the middle of everything. And you have to be really aware of what is going on that appliance because of all the attack vectors that are existing today.
So what started out as a function to enable better networking because of the shortage of IP addresses has really become a much more granular control mechanism, in your opinion. Is that right?
Yeah, absolutely. And the biggest advantage to that is not only that you can decouple your load balancing functionality from the actual IP address that is being used, but it also simplifies changes, especially if you need to migrate an application away from a specific IP address to something else. In the past, you had to reconfigure that load balancer with a new IP address and so on and so on. And now with content switching rules, you can basically say, okay, now it's this IP address. Let me just attach that rule to a new content switch, change the IP address in DNS so that the record comes up onto the other virtual server, and we're gone. So basically what used to be a complex operation in the past is kind of turning into a commodity change, which is driving costs down because you need far less time to implement some changes. So yeah.
So Jan, I got a quick clarification question for you. We're talking about granularity and stuff like that, which means looking deeper into the packet. Now, is there a discernible compute penalty over compared to, a simple layer 4 load balancing? Is this, a big problem for using content switching?
Well, there are a couple of things that are into play here. As content switching is much more common nowadays, to be honest, the way that Netscaler implements it is unique. It's not, well, at least Netscaler is not the only vendor that implements it in a similar way, but the way that Netscaler does it with policies and rule sets is quite unique, if you ask me. And if you then compare it to other vendors, you often see that they do implement some kind of content switching functionality, but it is more limited in a way that Netscaler basically gives you access to everything that happens on the network stack, from the IP addresses to the layer 4 controls that you want to implement, up until everything that is happening at layer 7, at least for web traffic, so to speak. I mean, there are other protocols that are a bit more cumbersome to deal with, but at least for web traffic, you get full granular control. And coming back to your question, does that have a performance impact? Yes and no. Yes, because you have to, the Netscaler appliance needs to analyze every packet that is coming through. They need to analyze the protocol and create all these objects, so to speak, in memory to be able to call upon them in your rule sets. But then on the other hand, the architecture of a Netscaler, which is single pass, basically negates the performance impact, because a packet comes in onto the network stack, the packet engine takes it off the network stack, and all those processing is already done before you even hit the first policy on a Netscaler. And from there on, every single module in the Netscaler is handled sequentially. So you only need to process a packet once on the way in, and then obviously if you want to do something on the return traffic, that's a second pass. But in a single direction, it's a single pass architecture, which makes it really unique. You don't have to route traffic through different appliances to get the same functionality, which for me negates at least the CPU impact. Yes.
Right. So it's, and I looking back in the history, and I know that a lot of early load balancers used to do things at layer 4, and they would use the hardware. I'm thinking of Altion here. I'm thinking of early days of 5 and stuff, which was kind of a switch with a a processor stuck on the end to do layer 7 stuff. So it would come up and then it would push stuff down and continue that conversation switching at layer 4. And yes, there was a penalty, I think, of deeper inspection, but that fast path, if you will, sort of negated that a little bit. But as we've moved forward in time, more and more, I think, has moved up the stack. And I think that NetScaler's single pass architecture has reaped a lot of benefits for them. Is that kind of in line with what you were saying?
Yes, absolutely. And I think another way to put it is that NetScaler has always been a software product, obviously also tied into hardware because hardware appliances were being sold and are being sold. But from the ground up, NetScaler, the packet engine was built as a software component, which forced the developers, in my opinion, to take care of the performance right away because they couldn't limit themselves to hardware acceleration. Obviously, when you bind the NetScaler software into the hardware, obviously you're gonna make use of all the acceleration technologies that are available from, for example, the Intel SSL chips or the network stack, obviously. But that's only the network part of things. The application delivery only gets interesting, at least for me, when you move up from layer 4 into the higher levels of the network stack or the OSI stack, so that you can do interesting things and have granular control over everything that needs to be done for that specific application before it's sent to the backend server or back to the client.
Right. So tying this back to something you said, much earlier, how does this, kind of start to get into that security conversation? How would you say that content switching provides security benefits over, IP and port load balancing?
Well, as most of the people will know, NetScaler comes with a range of modules to provide either load balancing or security policies. One of them is application firewalling, but application firewalling in itself is a quite heavy module. It's like using a shotgun to open a door, so to speak. And when you turn back into content switching, first of all, the fine-grained control over an application flow gives you the proper handlers to specify which policies should be enabled on which traffic. So you don't have to apply the same policy to every request that is coming in. And that's already a very powerful mechanism to reduce the load on your appliance. Because if you're gonna apply security policies onto each and every request that isn't subject to an attack, for example, static loading of images, for example, it doesn't make any sense to apply any policy there, because then you will drain the power of the appliance, whether it's in CPU, in software, or really on the hardware box. So that's one point. And kind of framing a modern term in the IT landscape is infrastructure as code. And I would say that content switching policies, in a way, are old school infrastructure as code blocks, because you have to, in the NetScaler configuration, you are going to define which request needs to be handled by which load balancing virtual server. So you have to provision that load balancer. You have to say which request needs to be routed in which way. And albeit that is not something like Terraform or Pulumi or one of the other modern infrastructure as code toolkits, you are specifying in the code what needs to be done. And content switching policies, because of their nature that you have access to everything in layer 4 and layer 7, allows you to specify an application really to the tiniest level if you need it to be that specific, obviously. And if you then combine content switching policies with the responder technology implemented on a NetScaler, which basically allows the NetScaler to respond to the client instead of the backend server, you first of all take load away from the backend, so the backend gets more resources which are available for the real requests, and you can basically implement a poor man's firewall, because at layer 7, not at layer 4, but at layer 7, because if a request doesn't fit what you define it needs to be, you can just reject it and send whatever response back to the client that is appropriate, whether it be a redirect or forbidden, or even redirect them to something else entirely. So yeah, the combination of both allows you to improve security posture if it's done right without having to resort to the big bang application firewall. And then you can limit that to the functionality where that module really shines.
So I think that's an important point that you raised there, Jan. And, content switching gives you the granularity. I think what I'm paraphrasing here, the granularity to really impose fine controls, almost teasing your traffic through in the right way that's right for that application, but not right for another application. So you've got complete control over everything. That's exactly what you're saying, right? And it really it enhances the security, because you're not just doing something at port 80 or port 443 and an IP address. I mean, it always struck me as the weirdest thing that we think SSL is secure, and yet we just let it through the firewall on 443 and get it to the server where it can unpack itself, decrypt itself, and do any damage that it wants. But I like your analogy of the poor man's firewall, the content switch, and the responder. That I really love. So just to wrap this into a question for you, actually. So, once you know what you're looking for and you've got that granularity, I'm going to guess that it's fairly straightforward in general, not just for Netscape, but in general, to set up content switches. Are there any gotchas that you've gained from your experience, or what do you do to improve your customers' environments?
Well, as you're already suggesting, Jason, architecting content switching the right way can be really challenging at times, because you really need to balance granularity with use cases and the amount of time that you need to put into administration of that granularity. Because obviously when you divide every application into 10 or 20 subcomponents, you're going to need to do a lot more configuration than just forwarding a domain, even at the basic level of layer 7, just forwarding the domain to a specific server. And getting to that balance, that's the real trick, if you ask me, especially if you have large applications or large code bases, whether it be on the application side or even on the Netscaler appliance itself. The larger your configuration gets, the harder it becomes to strike that balance at the right spot. From our experience, we used to have a customer actually that had a configuration on the Netscaler. I think it was 12,000 to 50,000 lines of code. So basically, that was a huge configuration, and because of the amount of lines of policies that we need to administer, it sometimes took us up to 2 or 3 days to figure out where we needed to put one specific new policy for a change or a new application or a new component or whatsoever. So a turnaround time of 2 to 3 days to implement the change, where you really need to focus on that change, customers aren't too happy with that lead time. Although they are aware that, obviously, because they have such a large code base, it is becoming more and more difficult. But basically what we got the opportunity to then redesign their complete configuration, and we really started to look at what is actually happening most of the time when you are processing web traffic. And that redesign project led to our open source CoreLogic framework, which is basically a content switching and responder kind of framework to configure a Netscaler properly. And that framework basically allowed us to categorize every request that we have and tackle around 80 to 90% of all the possible use cases that we've seen in the last 10 years.
And so you've designed as CoreLogic.
Yeah, basically, so Roel and I, before we started to work together, we already had some kind of rules that we implemented over and over again. And by working together, we were able to define that 80 to 90% of use cases that were out there, and then create a kind of framework around those use cases so that we just have to fill up a couple of tables, because that's what basically it turns down to. It's string maps, so key value pairs on the Netscaler, to completely administer the configuration. And by being able to have that 80%, especially for that customer, the new configuration was still 12,000 lines of code, but it was only 2,000 lines of code and 10,000 lines of entries in those tables. So by optimizing their traffic flows, by using that tables, we were even able to shave off, I think, 5 seconds in loading time from their web page, which is a lot, especially in these days, nowadays, because we don't have to roll through 2,000 policies anymore. We only have 10, and those 10 policies can do whatever we want. So the final result of that redesign project was that we were able to bring down implementation time, or the turnaround time for change often go down to 15 minutes. Oh, this is what you need. Let me look into it. Okay, I need to change this and this and this in these tables, in these key value pairs. And the change was done. And also from a documentation perspective, we just had to list out all the contents of those string maps from those tables. And we got a complete configuration of every application or every application flow that is running through the Netscaler. So if you do content switching the right way, it really helps not only us as a partner or as a consultancy party, but also the customer in terms of documentation and exact control of what is happening. And I think in this day of attacks and security incidents, knowing what is flowing through your appliance, that's the key right now. Because without knowledge, you can't start mitigating those risks.
This is quite a large customer with 50,000 lines of config. I think that's not common, not every day at least. And good documentation, proper planning, and proper implementation seems to be the answer. And especially, I know that you work a lot with the Kubernetes and microservices stuff. I would imagine from what you said, the more complex the backend environment, and then the more granular you want to do that can become quite a complex environment as well. Would you agree?
Yes, absolutely. I mean, if you look at Kubernetes, everything is defined in code because you need to configure your ingress controllers. But if you ask me, the spread of YAML and everything in there is also becoming a problem because the application sets are becoming so large that you really need to dive through so many lines of Kubernetes configuration files. So if you ask me, in the end, it will be some kind of combination where you can leverage the power of Kubernetes with the power that we have in our framework. I think that if you can strike a balance there, I think you have a really powerful setup, not only for the larger customers, obviously, because this project originated with that large customer, but we also use it for the very small ones, because when I do my work and I use that framework, a colleague of mine can just come in because he knows that framework as well, because we standardize our operations onto that. And basically, the only thing he or she needs to do is look at those tables, what is running through, and they know exactly what is going on that system. So the lead time into being productive for another customer is just reduced down to minutes, and we can focus on the real problem.
I think what I'm hearing here is another topic for another podcast. Actually, at the agencies, and I would love to have you back to talk about that sometime, but maybe we can do it in person sometime soon. I fan of content switching.
Nice. So we've talked a lot about, a lot of the good side of content switching, and we're kind of starting to look into the other side of the coin with, massive amounts of configuring and stuff like that. Are there ever situations where you wouldn't want content switching at all, where it's just, a bad idea, or is it really only a balance that you're trying to strike?
My personal opinion, I don't think it's ever a bad idea, but with some caveats. Obviously, there are some protocols that don't lean themselves to use content switching. If you talk about FTP traffic, SMTP traffic, and you don't get full access into the nitty and gritty of the protocol, and you can't control those, then it's hard to use content switching. When you use SSL bridging on a Netscaler, so basically you just pass the SSL encrypted or TLS encrypted traffic through the Netscaler without touching it, obviously you can't do anything with that apart from the networking layer, so up until layer 4. A little bit on layer 5 for the SSL part, but that's about it. But still, we've been able to find some ways to introduce content switching even for those, even if it's only as a backup when the SSL bridging virtual server goes down, because then you need to do something as well without relying on a backend infrastructure. So content switching can still help in those use cases. But even for simple layer 4 port forwarding like we used to do in the past, I would still use content switching because, again, if you set up the rules appropriately, you will get documentation from a single source instead of having to look at every IP address and port combination that there is. And decoupling traffic entering the appliance from how it is being routed or flowed through the NetScaler and from the way it is sent to the backend, that's powerful. It's very powerful, even if you're not using content switching to do something at layer 7. So I would basically always use it whenever possible. Yes.
Okay. Now, you seem to be a big fan of content switching, and we've discussed many of the advantages. I feel and I see that there's somewhat of a shift back towards basic layer for load balancing. Do you see that happening? I'm thinking, buy a load balancing service, and then the coders will say, well, I'll just code this in if I need that or something like that. So do you see that? And we spoke to another partner recently, and he was talking about this is what he saw in the cloud, lots of people doing separate services for everything, and then thinking actually consolidation would be the way forward. But do you see this with content switching being, it moved forward? Is it receding again? And is that a mistake?
I would say that's a tough one. I mean, in the microservices world, especially with Kubernetes, ingress controllers are increasingly applying layer 7 rule sets. They're increasingly applying security policies. So especially if you're going into a full service mesh architecture, it's all about the discovery of the backend, splitting up applications and services so that they are handled by the right service on the right node at the right time, and not having to go through massive appliances that need to do some logic. So it's built into the service meshes and the ingress controllers.
Right. Mm-hmm.
But basically what you're doing is content switching. It might happen at a higher level, really, in the application or in the Kubernetes control plane that is directing how the routers and the application delivery appliances that live in there need to be configured. But you're still doing content switching in the end, especially with the full service mesh. Now, obviously, microservices are all the hype nowadays, but you hear a lot of voices coming back to monoliths because the microservices world has blown up a bit too much. I think we went to the extreme with services and containerization, and you see a shift back there. But there is still a shortage in IPv4 addresses. There are still applications that must be made available. And given the increased focus on security, I would say applying the right policies, the right security policies at the right place will drive the adoption of content switching. So there might be a slow shift back to layer 4 load balancing right now, but I would say that's rather because of some of the products need to catch up to what is really required in the modern day world of application delivery.
Interesting. You raised this shift, this explosion of Kubernetes and microservices, and then coming back to monoliths. And it's a topic of conversation in my house about which is more secure. And I would like to reserve your judgment on that for a future podcast as well. I know others would also want to get involved in that topic, but very, very interesting insight on that.
Nice. So we are starting to get towards, the end of our podcast here. And, we've talked about a lot of cool things from, content switching to ADCs and, the microservices in between, that explosion we've talked about. And we always like to ask our guests to make some type of bold prediction. Is there anything along, our discussion that you might like to make a prediction on?
The short answer is 2024 will be the year of NetScaler. That's one. No, a more serious answer to that, I think more and more application infrastructure will move back from clouds, from public cloud to on-premises infrastructure. And I really believe that appliances such as NetScaler that are able to work on many levels of the stack will drive that motion back to on-prem. Because if you look at the functionalities provided by public cloud, you really need to tie a lot of services together to get to the same point of functionality that a NetScaler, for example, can provide. And couple that with the increased costs of running services in the public cloud, especially for applications that aren't built in-house, but that you just need to deploy and you're not in control of how you can servicify those components, I think it will become more and more important to get back to on-prem data center and do your thing there. Absolutely. So that's my prediction.
Okay, thanks for that. That's going to be an interesting one. I kind of agree with you. We shall see. But anyway, so just to summarize, content switching, in my opinion at least, and I think it's shared in others, that it was the transition from load balancing into ADC world. That's when we started to really move in that direction. It brings a lot more granularity and fine-tuned control and specialization, differentiation for customers and access and stuff like that. And then when coupled with the right responder policies, it becomes the poor man's firewall. I like that analogy. And you've got so much more security control with your NetScaler, with your ADC, using content switching. I love that. That's really good. There are very few use cases where you wouldn't want to put the content switching. And although it can, obviously you're inspecting deeper, it can take more CPU. The way that it's implemented in some ADCs like NetScaler, that is negated, and you can use content switching like you would do normal layer 4 to 7 layer 4 load balancing without any problem at all. So with that, I think that summarizes everything, and it just remains for me to say thank you, Jan, and back to you, Brian.
Yeah, thank you so much for joining us, Jan, and thanks everyone for tuning into this episode of the NetScaler podcast. You can find our podcast on Spotify, Apple Podcasts, Google Podcasts, or the NetScaler community website. You can also find us on YouTube if you'd like to watch the video version of this interview. If you're already here, leave us a comment on what you thought, what you might like to hear next. Thanks so much.